In this segment, I'm going to show you how to use a PT100 temperature sensor, as shown here, with the SEElab or the ExpEYES kits. So I've made this connection here. Let me show you in the camera here. So you've got the PT100 sensor, which is basically a resistor whose resistance is a function of the temperature. And I've connected it between PCS here and ground. And PCS is set to 1 milliamperes constant current. And if you're on the ExpEYES device, then it's CCS, which is fixed at 1.1 milliamperes. So here you have a programmable current source set to 1 milliamperes. Now, at 1 milliampere and 100 ohms of this device at room temperature, you should get 100 millivolts voltage drop across this. And as it heats up, you have a change in the resistance. Now, I can either measure this internally using the PCS's voltage monitoring utility, or what I've done is I've connected a wire from PCS to A3 for simultaneous monitoring. Why? Because if I connect a 1K resistor between Rg and ground, I can amplify the signal by about 11 times. So the formula is 1 plus 10K by Rg. There's an amplifier inside. So the 100 millivolts actually becomes 1.1 volts by the time it reaches the output stage of A3's processing electronics. So this gives me finer resolution. Now with these connections, let's look at the user interface. So go to advanced section, PT100 logger V2, and here you've got controls for PCS available if you're on the SEElab3 device. So if I drag this needle, I can change the current source. And accordingly, you can see that the voltage measured by A3 changes. But because we've specified what is the resistor we used for Rg, it can back calculate the actual voltage across the PT100 sensor. Now, of course, for higher currents, you'll get a higher voltage drop, but the formula for temperature remains the same. And the temperature here is about 26 degrees. Even if I change slightly different, you still get the same temperature. Okay, so let me just click this and make it 1 milliampere fixed. So the schematic diagram is here. Now, looking at the graph on the other side, you've got temperature versus time. You can specify the duration you want to record for in seconds, the interval. So let me make it, let's say, every 100 milliseconds, and just click on start. So if you click on start, whatever values are being recorded here are also now simultaneously plotted. So let me heat this device using a small lighter. Okay. Yeah. So there's a small lag because of this huge metal case. It takes a while for the entire thing to actually heat up. So I gave a short burst of high heat with this lighter. And yeah, it's taken about 5-6 seconds to stabilize. Now, if you're using something like a water bath for the Newton's law of cooling experiment, this shouldn't be much of an issue. Everything is slow there. But it's not a very fast responding sensor. For that, you'll probably have to break this metal case or buy a PT100 sensor, which is just a very small, about 1 mm by 1 mm element. Right. So that's about it on how to measure temperature. You can also save values as comma separated values, which you can open with Excel or Calc or whatever. And let me just heat this to a higher degree. Let's see how I can heat this. Yeah. It's going to quickly exceed 100 degrees. So at 100 degrees, I can melt this foam. Okay, thank you.